Hello everyone, and welcome to a quick introduction to hardware design as part of our junior design course at the Georgia Institute of Technology. For this video, there are two key points that I want you to take away once you're done watching this. The first key takeaway that I want you all to know is to know what's driving component selection. And I'll bury the lead here, but I want you to walk away knowing that your choice of components isn't based on, say, something that you're familiar with, you used in the previous class. The main thing that should be driving your choice of your components is the requirements that flowed down. The second thing that I want you to take away with is the interplay between printed circuit board or PCB design and the mechanical design process. So we're going to go over PCB design in greater detail in the future, but in the meantime, I just wanted to give you a feel as to where the PCB design process falls in the overall hardware design flow. And then the third thing is just a quick tour of component selection. Specifically, we'll just look at a key example of using DigiKey, which is a very popular site for sourcing components. And we'll go through the search for a particular component so that you can have a feel for what the process is. And hopefully all of you will be comfortable exploring DigiKey as a way to identify components that meet your requirements. So let's get started on your component selection process and what's driving it. So as a quick review, remember we have our design process that starts with the customer requirements. And then you go through your V process where you flow down your requirements, and that's kind of the design phase. And then once you figure all that out, you have all your requirements, you start building, and then on your way up, you start testing. And as a quick review, what's this process going up called? That's verification, right? So to make sure that everything that you built met the requirements, and you continue to test that as you work through the various levels between system. I should just review. Right now our overall hierarchy is system, and then we go to subsystem, and then components. So as you go from custom requirements down to system, subsystem, components, this is the key takeaway here, what is driving the information that's flowing down to each of these lower levels? It's the requirements, right? This process is called requirements decomposition. So you develop the requirements so that you can wrap up everything that's relevant to a subsystem into one little closed package that you can hand off to a separate team of engineers that are working at the subsystem level and say, meet these requirements and we're good. Similarly, once you get down to the component level, your subsystem will have a set of component requirements that flow down to the components. And these you can flow down, if you're a big enough team and you have dedicated component engineers, these would flow down to the component engineers and they would start that portion of the design. Once you have it done, you build and then test your way up as you integrate, and that process is called verification. And then when you get to the very top, what's that called? That's right. So the final step is validation, where you make sure that what you build, what you put together, still meets all the customer requirements that were there in the beginning. So the main takeaway that I want you to carry with you is that once we start doing the PCB design and doing the hardware design, you're going to start looking at components. And the main thing to remember is that everything starts with the requirements that came down from the subsystem level. So you should have a clear set of requirements that are flowing down to the components, and then use that with an open book where all the components that you have access to are on the table, and use that to perform an objective selection to make sure that you have the most robust solution possible in your engineering process. So that's item number one. Remember, so requirements drive components. The second thing that I want to talk about is the PCB design process. So In it, like I said, later on, we'll start talking about printed circuit board design. But the main thing that I wanted you to take away is that in the grand scheme of things, you have your electrical design, which includes, once you have an idea of what you want, you start designing your printed circuit board. That will be the form factor that you implement your hardware design in. Now, when you do this, the other thing that I think that's unique about printed circuit board design is that separately, many of you have a mechanical subsystem where you have a separate design effort. And compared to other efforts like software, there is a large amount of interface that goes between the mechanical design and the PCB, because ultimately the PCB will have to be mounted into the mechanical enclosure somehow, right? And that's specifically the case nowadays, even more so when our devices are getting, our overall systems that we're designing are getting smaller and smaller. So often you will have more unique shapes of PCBs and tighter integration with less clearance between the PCB and the rest of the housing. So this kind of close co-development becomes especially important, especially in the case of PCB design and mechanical design. And so there's this iterative process where the electrical team, you'll develop the circuit, you'll lay it out in PCB, but then there's a separate part where you want to interface with the mechanical team, make sure that it fits, and also think early about how you want to mount the PCB into the housing. So are you going to have mounting holes and standoffs? If that's the case, start while you're doing the PCB design, since you're going to have say through holes in the corner. Have the mechanical portion of how you're going to mount it as part of your design process. So have the fasteners or whatever approach you want to take selected, have your standoffs selected, and make sure that the required dimensions are incorporated in your printed circuit board layout. And another important thing to keep in mind is that when you mount the PCB, there might be a certain amount of flex as you tighten it. So also make sure that you have a certain amount of clearance of your components away from the clearance holes, especially in the case where, say, you have ceramic parts or parts that are very brittle. You definitely don't want them close to these through holes where flexing might occur and your parts might break. So we'll talk more about that later, but I think, and then once you have this iterative process where we've converged on a solution for the PCB as well as how you're going to mount it, then you get it and hopefully you assemble and test and everything's dandy. But if not, you might have to go back and do a redesign, a respin of the board, and readjustment of the mechanicals. And so this particular aspect of hardware design is particularly interdisciplinary, and in many ways, aspects of these are more of an art than are equal parts art and science, and with things that you just have to pick up with practice. So I think that for those of you that are doing this for the first time, it's hopefully the start of a new craft that you can hone, and if you figure it out, I think that will only make you a more valuable engineer.